please, you can start with the presentation.
Thank you, Gabrielle. As Gabrielle mentioned, my name is Scott Bergeon, and we're going to focus on three main products that are with a new release that's about to come out. We'll talk about car real time, then we'll talk about VI-WorldSim, and then wrap up with some status changes on VI-DriveSim, followed by the Q&A. For more than 15 years, VI-Grade's been developing a real-time to-be-driven multi-body vehicle model capable of covering multiple automotive disciplines and applications, from your workstation to the driving simulator. That solution is VI Car Real Time. Looking at automotive vehicle development, companies face a number of increasing challenges. Vehicles need to be developed in shortened timelines. This includes reducing both time and cost, driving a need to use fewer prototypes and expensive physical testing, all in a complex environment of collaboration across the supply chain. Looking at integration, the simulation ingredients needed to this phase are mainly, first, a vehicle model where all the parts and systems of the vehicle are modeled with one single environment to simulate the entire system from tires, chassis, powertrain, steering, controllers, and ECUs, and more. Of course, the vehicle has to interact with a road model to accurately and precisely reproduce a realistic test scenario and interaction between the vehicle and the road. And then for offline analysis, you need a driver model that's able to simulate different scenarios and situations as in a real test. VI-Grade's solution answering these issues is our complete vehicle model environment for accelerated vehicle development. That's VI Car Real Time. VI Car Real Time has been out for a long time, and it gives you the power to design, integrate, and test all your systems to achieve virtual sign-off. This includes a complete environment to build and analyze vehicle models in real-time platforms, provides a unique solution with seamless integration to detailed multi-body models in Adam's car, using a robust driver model to capture any kind of driving event. And on an open platform where we have focused on interfaces to third-party models for tires, software in the loop, hill platforms, and seamless integration on our family of driving simulators. So let's focus on what's new in VI Car Real Time in the upcoming, soon-to-be released 2021.3 product release. One major feature of Car Real Time that is new is template-based suspensions. Traditional Car Real Time models use a curve-based approach to suspensions. There's a number of pros for this curve-based approach that allows you to capture many different suspension architectures with one unique numerical model, and it's computationally fast and reliable. It also allows you to evaluate vehicle behavior based on desired characteristics, even if you don't really have a physical design yet. And last, curves can be test-based or generated externally from geometry. So you actually have, in the prior methodology, the ability to both look at curves coming in from, say, a KNC test, or generating them from an internal tool that's existed in parallel to Car Real Time called Suspension Gen. The downside of this approach is the geometry and the bushings suspension curves are based on is not apparent once you're in Car Real Time. You have a set of curves and you can lose track of the geometry that they're based off of. And it doesn't allow you to explore variants of the existing suspension configurations where you might have design parameters that you're going to actually modify, and that means hard point positions and the bushing rates. They're sort of obfuscated into the curves themselves. So as part of 2021.3, there's a new approach that's based off of the Suspension Gen external tool brought in as templates directly inside Car Real Time. The advantages of this are it is direct hardpoint and bushing rate based parameters right native inside Car Real Time. It uses and exposes the built-in investigation mode to allow you to set up DOEs and use hardpoints and bushing rates as candidates for that study in a way that couldn't be done internally before. So there's easier integration with external optimization tools, so you don't have to wrap a optimization process that includes both suspension gen and car wheel time. You can just run car wheel time directly. And it keeps traditional numerical models in the background from the solver standpoint. The downside of this approach, if there's any, is it's an alternate approach to direct CAN-C measurements. So if you've directly measured CAN-C data, you would probably still rely on the traditional approach. And adding new reference templates so that if the architecture of the suspension changes, that takes a little bit of additional development, just like it always has in suspension gen. So with that, we've got a little pre-canned demo that'll walk through a template-based suspension, what the panels look like, a design change, and running an investigation study. Gabrielle, I'll turn it back to you. This demo shows using a template-based suspension subsystem. Let's start by loading a demo model, and let's make a clone of it. A clone's a local copy in memory of a model that can be used for modifications and studies and can be saved if you want to keep it. Let's add a template-based front and rear suspension. There are a number of templates to choose from. Let's use a McPherson strut for the front and a multi-link suspension for the rear. Hit apply, and the model is ready to be used. Switching to the front suspension subsystem, you can see there is a new suspension viewer similar to suspension gen. It's dockable, and it shows the geometry layout of the suspension. It's also dynamically coupled to the suspension geometry so that when you select a hard point, it is highlighted in the viewer on which point is selected. Updated coordinates are immediately reflected in the suspension viewer. In addition, the orientation of hard points that can have bushings are also shown and can be updated, at least when not in kinematic only mode. Switching to the bushings tab, you have the ability to adjust scaling or preload for the bushings in 6 degrees of freedom. And you can also access the property file, which can be set to either linear or spline-based for nonlinear rates. This is also a new feature compared to suspension gen. And finally, the suspension analysis tab, which is also a new feature, allows for setting the range of jounce and forces, as well as the discretization steps needed to map the geometry in traditional kinematic and compliance curves. Now, with these changes, the rest of the suspension is adjusted. Compliance and kinematics tabs are removed as the curves will be automatically computed. Also, motion ratio or compression ratio curves are removed, while attachment points on the chassis for springs and dampers are added. Let's run a simple event with an investigation to show the power of this new approach. I'll set up a step steer event on our clone model. Now, add an investigation based on the event. If I filter, for example, on upper mount, the coordinates of the hard point are immediately available as candidates for the investigation. Let's add the longitudinal position to the investigation and give it a short name. Looking, I see the nominal value is minus 32.81 millimeters. We'll allow it to vary in a range of minus 20 to plus 20 millimeters for its original position. We'll add a response called steering wheel angle torque max and assign the steering wheel torque output channel to map to it. Let's run a full factorial study and look at that response across the range with 11 different levels. We can select the number of processors to run in parallel. Since I selected the simulation mode to be in background, the car real-time interface is available to use during the simulations, as opposed to interactive mode, which would lock the interface. Once the simulations are done, we can view the design space and results. Now we can see that changes in the longitudinal position of the hard point obviously have an effect on the maximum steer torque for this simple step steer event. This demo highlights the major advantages of using template-based suspensions to allow studies of the suspension geometry and compliance. Okay, that was the full demo.
So Scott, you are presenter again, so you can share your slides again. Thank you.
Okay, thank you, Gabrielle. Another area of improvement for car real time in 2021.3 is model obfuscation. Model obfuscation allows you to share models with partners and suppliers while maintaining the IP in the model. With this new version, we've added a vehicle override file that's where it's possible to modify a predefined set of vehicle parameters, vehicle masses, sensors, and even the entire advanced steering system as an example. You can also get at and change which tires are on the model from a simple tire model to a complex tire model as an example. And basically this is all done where none of the parameters in the model are exposed other than the ones that you put yourself into this vehicle override file. So that's an extension from what the capability in the current production release is. A third major area of improvement in car real time 2021.3 is in the model conversion process from Adam's car to car real time, which is done through the car real time plugin to Adam's car. There are new wizards to streamline the Adam's car template preparation. All the major template major role, like suspension, powertrain, steering system have unique new dialog boxes. Automatic communicators are set up, and it supports rich templates like body rack and pinion steering and the body subsystem. So a fair amount of investment that went into that. You'll have to go through a little bit of work the very first time you set up conversion for a particular model, I'm sure, but hopefully that process is significantly improved. Finally, for car real time, there have been some continued investments in steering models that are critical to the steering feel response as experienced on our simulators. One area is we've increased from 1 to 3 potential EPS maps that are available for electric motor current as a function of torsional bar deformation. This allows you to not only make a switch of the map at design time, but you can also modify at runtime using a dedicated steering system input. This allows you to offline do some studies, but it also exposes the ability to switch maps easily once you get to an online environment. Another feature that's been added is eccentricity in the steering column mass. So you can put an offset, both lateral and vertical, that allows you to control the phase and introduce a sort of a first order harmonic of the steering wheel versus your steering motion. Another function that was added was ability to put in rigid torsion bars, which previously you couldn't do because the way that the EPS map was dependent on that. Okay, that's what I had for VI car real time. Now let's focus on VI-WorldSim, which is the VI grade solution with a focus on ADAS development. If we go specifically into ADAS and autonomous vehicle development, automotive companies and suppliers must focus mainly on 3 specific challenging tasks. Perception. The car we are driving must be able to perceive the external world around it made of other cars, other type of vehicles, pedestrians, sometimes animals, road work, that kind of stuff. Prediction. All information collected by the sensors must be combined, verified, and merged into inputs for the control algorithms. This to predict the behavior of the autonomous vehicle or assisted vehicle. And finally, planning, where all outputs of the control algorithms are sent to the vehicle actuators, such as steering wheel, throttle, brake, and others, to safely drive the car through the predefined mission. In the two perception and prediction phases, the needed integrations are mainly a realistic ego vehicle that moves around in the environment with the correct dynamic behavior, where the ego vehicle is controlled by the driver, whether it's a human on a simulator or otherwise offline, which we'll talk about in a second. You also need traffic and agents such as pedestrians, animals, bicycles, that kind of stuff. These elements have to move in a realistic way. And then sensors required to perceive which objects and entities are in the vicinity of the ego vehicle. If we look at the way ADAS and AVs have been developed so far, it's clear that we need to move from public driving to virtual development and testing. This methodology shift will allow us to accelerate innovation and develop new ADAS and autonomous vehicles in less time, with less risk and less cost. Our solution is the high-resolution graphic environment for accelerated vehicle development called VI-WorldSim. WorldSim's been around for about a year. And with WorldSim, you can drive a vehicle on a driving simulator in a high-resolution replica of the world with realistic traffic behavior. VI-WorldSim has fully integrated with VI-grade existing technology for both offline and online simulations. It's easy to use thanks to its desktop editor, and it's equipped with high-quality graphics based on the Unreal Graphics engine. VI-WorldSim also has been optimized for use in conjunction with driving simulators. It's integrated with all VI-grade simulators from a desktop up through the large dynamic simulator, driver and motion simulators of any size. It's optimized for multiple projector systems with large screens, and it's unified for seamless transfer of vehicle models from offline to online activities. An area of major development for VI-WorldSim 2021.3 is in a brand new offline analysis capability. This is a new package independent from running WorldSim connected through DriveSim for simulators, and it's focused on running offline. It's directly integrated into MATLAB Simulink in a similar way that car real-time is. And what it basically exposes into that Simulink environment is all the sensors using standard math toolboxes. There's some integration between car real-time for seamless use, and it extends the offline sensor controller design process to include the full richness of WorldSim environment directly exposed into that Simulink environment. So we have another CAN demo for WorldSim offline. Gabrielle?
Yes. Just a second.
This demo shows the VI-WorldSim offline capability to integrate with MATLAB Simulink. Let's start in the WorldSim studio by building a simple scenario on a straight road. We have an ego vehicle in the right lane and a traffic vehicle on the left. The ego vehicle will be driven by a car real-time vehicle dynamics model. We have a set of virtual sensors, one camera and one virtual camera. Let's save the scenario and close WorldSim Studio. The WorldSim offline package contains three main components. The first is a set of 4 scripts to start WorldSim, load scenarios, unload scenarios, and stop WorldSim. The second main component is the executable components for WorldSim process itself. Let's run a script to launch the WorldSim offline process and load the scenario we just built. The third main component is a library of WorldSim related utilities. Here we open a simple example Simulink model. You will find inside the Simulink library browser a VI-WorldSim library. The library contains a utility for syncing the Simulink and WorldSim processes, There's a block for sending data from a car real time to the WorldSim environment to be used by the Eagle car. And then there is a complete set of sensor blocks. For example, the camera, virtual camera, radar, LiDAR, and so on. In this example, we have a car real-time plant model for the Eagle vehicle. The model is based on a simple sedan vehicle send file that we distribute in the installation directory, which of course could be replaced with your own model. You can then manage the input signals to the car real-time plant model. In this case, we use just the driver demand steering input. For our output, you can export through a virtual bus all the channels that are produced by the car real-time model. So the data flow is the car real-time block is computing the vehicle dynamics and is sending that to the WorldSim Eagle vehicle. The block of the controller is synchronizing car real-time and the VI-WorldSim environment. On the right, we have a sensor block. In this case, it's a virtual camera. If you double click on it, you can set the options. For example, you can set the WorldSim actor that the sensor is attached to, which we want here to be the Eagle vehicle. You can then select the sensor name in WorldSim that this block in Simulink is associated with. There are some additional parameters to manage the number of outputs. You can see that there are a number of potential outputs from the virtual camera sensor. For example, we selected export of a polynomial coefficients for the left and right lane. In this case, what we have done here is to produce a very simple lateral controller in Simulink in which we grab the lane polynomials as input and export the steering command to feed the car real-time plant. This closes the data loop. So when we now run the simulation and we go to the WorldSim environment, we see that there is a simulation where the vehicle tries to stay inside the lane. Obviously, then, it is a matter of tuning the lateral controller to make it smoother and better than this. This completes the example of offline integration of WorldSim with MATLAB Simulink. Okay, so hopefully that gave you a feel for what the offline new utility, how it works.
So now you can present again, Scott. By the way, I see that someone wrote in the chat that they were not able to see the demo. We believe that it was just an individual case. If you have problems in seeing the webinar, please refresh the view of the webinar environment, and that should resolve the situation. In any case, the videos that you have seen or that have been shown during the webinar have been also uploaded on our YouTube channel right now, so you can go and re-see basically the same video once the webinar is over. Sorry, Scott, for the interruption. You can go ahead, please.
Okay. Thank you, Gabrielle. All right. Another area of improvement that's new in VI-WorldSim is the SDK kit. There's an improved process for importing user-defined road environments based on MathWorks Roadrunner tool. This is possible through a three-step process. First, you design the environment content using MathWorks Roadrunner tool. So what the full capability of that, you design the environment, you get all the streets, the lights, lighting system and all that set up. Next, what you do is you use this new SDK kit to import that Roadrunner format. It reads in that file and it generates a WorldSim format file that can then be deployed directly using the WorldSim Studio. We do have videos for each one of these three steps that are more of a tutorial than an introduction, and the processes described in videos that are also available on our YouTube channel. You can just search for the word Roadrunner and the 3 videos should come up. And of course, VI-Grade is continuing to invest in increasing the number of tracks and road network environments available in the WorldSim environment. In addition to the M-City environment, there's a Wolfsburg network, which is what's animating on the right. We've added Calabogie, Hockenheim, Idiota Dry Handling, Aragon, and Thunderhill. And shortly, not tied to the actual 2021.3 release, but not waiting for another release, is continuing content development for VIR, for Nardo Technical Center, for the Nordschleife, and also for Thetford, which is the first environment that's specifically compatible with left-hand drive vehicles. As part of the continued investment in WorldSim, we have an updated licensing structure too. So for online simulator, there are two packages. There's a basic package that has all the core SDK, the API functionality in it, all the integration required to make WorldSim interface and run on the simulator and connect to VI-DriveSim is included. The scenario editor, the vehicle database, most of the standard environments are all there. And of course, some ego vehicle dynamics are included. What's not included is dynamics of other actors in the environment. So think of the basic package as being equivalent to and analogous to the environment that exists in VI-DriveSim now. So if you're running on a track and you're interested in driving the ego vehicle and you don't really necessarily need all the sensors and dynamics, the basic package is the right package for you. And then there's an advanced package that sits on top of that where all the sensors, the dynamic traffic and pedestrians are enabled. There's a lighting that can be defined so that you get proper reflectivity for lighting. The Euro NCAP tests are included there. And then some of the other more advanced environments like Wolfsburg will be packaged into the advanced package. The sum of those two packages together is sort of a bundle called Online Full. And then in addition to that bundle, if you have additional screens that you want to have channels driven to, there's options that are basically display dependent. And then that Roadrunner interface that we just talked about. So that's all packaging that's around running WorldSim on a simulator. For the offline capability that we just demoed, there's a package for that too, and it exposes all of the functionality into that Simulink environment. What it also includes is packaging of the car real-time solver, so that the demo that we showed with this full package would be completely enabled. At least it would be completely enabled with the sort of generic send file that we gave you. If you want to build your own vehicle model to get in there, of course, you would separately need car real-time to set up that model environment. And then it also has the same Roadrunner interface. And finally, that package is really designed for running offline. If you wanted to use those same licenses and sort of share them for doing offline work, but also run them on a simulator, there's an upgrade package or interface for all the driving simulated graphics and motion compensation and that could be added to that offline. And then you've got a set of licenses that will run both online and offline. So there's some overlap there. As investment in WorldSim continues, we want to help the VI-Grade community with some commercial offers for migrating to the WorldSim environment. So there's a promotion that's running from basically now through the first half of next year, where existing VI-DriveSim customers will get a WorldSim Online basic packaging product for free, and we'll get a 50% discount on the advanced package. Both of those, so that's what it would upfront cost would be. Of course, once you get into year 2, the maintenance fees would revert back to normal based off of the list price. And then that same environment, or this online full bundle, is being packaged and put on all of our simulators going forward. Okay, so that was the content I had for WorldSim. No discussion of VI grade solutions is complete without talking about driving simulators. And the software solution at the heart of our driving simulators is VI-DriveSim. When you implement a driving simulator, if you face several different challenges that are coming from different sources. From the financial department that's asking for an immediate ROI and investment payback, from the development team that's asking to shorten the development time and to decrease the number of prototypes and tests, and from the entire organization that's demanding for more integration and collaboration centered around the simulator. In order to win those challenges, you need to have a seamless integration of hardware and software. A motion platform alone is not enough to reach those goals, and a bunch of different software is not enough to give you the best driving experience. Only when the hardware and the software are working in sync do you have a driving simulator that allows you to obtain unprecedented results. VI-DriveSim is the software platform that enables easy and complete control of all components of our VI grade driving simulators. VI-DriveSim, as all other driving simulator components, follows the VI grade philosophy of providing a complete, unique, and open solution. It's complete because it's a comprehensive software platform to manage driving simulators in all aspects. It's unique because it drives VI grade unique motion platforms for the highest possible performance. And it's open because it enables the use of third-party solutions for vehicle models, for tires, hill platforms, and scenarios. Some areas of continued investment and improvement in VI-DriveSim. The firmware is updated for active brake and steering to enable newer DriveSim versions to be implemented without changing the driving firmware. A new custom mapping mode for the IODB hardware map's been added that removes the need to build a Simulink-based model for the hardware map. And integrated support for cable-driven simulators is now done so that a single build across the full lineup of DIM simulators can be used where that was separate before. So that concludes the presentation part of this webinar on the upcoming 2021.3 software updates. The release of that version is scheduled for Thanksgiving Day, so November 24th this year, just coming up shortly. If you're interested in a demo, please give us a contact. You can go to our website directly. You can also contact me directly if you want to. With that, I want to open up the discussion for Q&A.
Yes. So thanks again to Scott Bergeon for the interesting presentation, and thanks to all the attendees for being with us. So now, as Scott was saying, we are ready for the Q&A session. I think, Scott, you can start answering the questions that have been submitted beforehand, the questions that you show there. In the meantime, there are other questions that have come in, and I will read them after you answer these questions. And any attendee who wants to ask a question, please feel free to punch it into the chat window. Please,
okay, thanks, Gabrielle. The first question we had was, how does suspension gen work with the new car real-time suspension templates? Is it still needed? The answer to that's, it's not needed, but it's still supported. In the release, you can still get at suspension gen. In fact, you can even take one of the templates if it's loaded in your model, and in the utility section of the car real-time tool, you'll be able to export out the suspension gen file that's equivalent to what is inside car real time. So that'll set up a suspension gen file, and then you can run offline if you want to. But all the functionality that we showed in that demo, all the nonlinearity capability, although it's built inside suspension gen, it's not really required because you can get at it directly natively inside car real time now. On the other hand, if you want to be able to still generate the K and C type curves, you can use suspension gen. You can also export those out of the car time piece. So that's the answer to that question. Second question was, can VI-WorldSim online package licenses be used to run offline? And the answer is yes, as long as, so you can, just as I said, you can take an offline package and add an extra upgrade to allow it to run online. If you buy the online package and it's sitting on your simulator and you want to on a computer that, say that the same one that you would be running WorldSim on the simulator as the main process, you also wanted to be able to run offline. As long as it's attached, has access to the license files, yes, it's fully enabled. So you could do both offline and online based off of a full set of online licenses. Third question was, how are traffic and sensors handled with the online basic package of VI-WorldSim? So I said there was two packages. There's a basic package for online, and then there's an advanced package. And in the advanced package is where all the sensors and the traffic is handled. But actually, the WorldSim Studio is part of the basic package. So you can still create traffic in the studio. You can set up all the sensors, and in the studio view, if you've used it, you can still have that sort of preview that'll run the animation, all the traffic will work in that, and you can see it. But then when you switch to running online, that traffic, any pedestrians and that will all be sort of statically frozen. They'll be there in the environment, but they're not going to dynamically move. To have those agents acting, you'll need the advanced package. Okay, so that's my answer to those three questions. Gabrielle, do we have any additional ones?
Yes, we do actually. So the first question is related to whether the new environments, meaning the new tracks available on VI-Car real time, will be available on VI-Car real time for vehicle dynamic simulations.
Well, first, when tracks are created for WorldSim, they come in, there's two pieces to them. There's the graphic environment that's useful on the simulator, and then there's the road file that is used to interface with the tires. And of course, the road files are there, so you can run car real time offline on those same road files and be able to do offline analysis. And then when you switch to online analysis on whatever level of simulator you have, it's there. So I think the answer is yes.
Then there is another question that is how the licenses are different between VI-Car real time and VI-WorldSim. I think there was probably some confusion and understanding that these are indeed two different software packages and they are characterized by two different licensing systems. Yeah. But maybe you want to further elaborate on that.
Yeah, and one thing that might not have been clear is I mentioned that for VI-WorldSim, WorldSim offline, it includes the VI-Car real time solver. So when I did the WorldSim demo, there was in Simulink a block that represented car real time, and it pointed to a send file, so there was a vehicle model there. That is all completely enabled as part of the VI-WorldSim licensing, that solver integration. Totally separate from that is car real time, and car real time, the offline analysis that you would do for creating models, setting up those send files, or running offline analysis itself. So the two are kind of They have overlap, both offline now and also on the simulator, but they're two totally separate packages. They have their own separate licensing. So if you ran the same scenario that the demo for WorldSim did with just WorldSim enabled, it'll work. You'll be able to run that generic sedan model that was provided with it. What you wouldn't be able to do is put your vehicle model in, make changes to the suspension hard points like we showed in the first demo, and then have that implemented and run offline. That to do that setup part, you need separate VI car real-time licensing. Hopefully that answered that question. Gabrielle?
Yes, I am just checking other question. One question is whether it's possible to use VI-WorldSim 2021.3 in combination with older versions of VI-DriveSim and VI-Controller 20.3, or is an overall update of all modules needed?
Let's say I'm pretty sure that you would have to update them all together. That's definitely the environment that we've tested with. And that would include, depending, I think you could still get away with running an older version of car real time. I'd have to look into that to see if there's any real difference on the offline integration. I'm not positive about that one. But I'm pretty sure that if you were going to migrate to 2021.3 for WorldSim, you're going to have to migrate to 2021.3 for DriveSim also.
Another question is whether there will be any improvements to body on frame modeling.
That's a good question. In this release, there's no specific focus on that, but it's definitely on our roadmap. We're actually working on in a couple of different ways right now. There's some looking at extending in the direction of modal content as a possibility. That's always a challenge from a real-time solver standpoint. And then separately from that, we're doing some work looking at what is the capability for doing secondary ride in a way on a simulator that leverages the car real-time model that's really more focused on vehicle dynamics simultaneously. So we have some projects working on that. It's definitely an area of focus for us, but there's nothing new in this particular release. I think that's more going to be a 2022 kind of a thing.
There's a question about testing and training an ADS system. So the question is whether VI-WorldSim would allow the detection boxes or driving path to be shown in the VI-WorldSim display.
That's a good question, and it's one that I'm going to take as a no. If we can capture who the question came from, I'll make sure to cycle back to you on that one. Because I could see where that would be definitely a useful thing to do.
So this one we will answer offline to the gentleman that asked it. Okay.
Yeah, I just need to do a little homework first to be able to answer that one properly.
So I think that at the moment I have no further questions that have been asked. There is a couple of remarks that I would like to provide before closing the webinar. First of all, is related to the material that we have uploaded in the webinar environment. There are 3 PDF files which are related to car real-time WorldSim and VI-DriveSim. It's basically some information material in PDF format that can be downloaded directly from the webinar control panel. So you should find it there easily. So these documents feature a detailed overview of our real-time software product line. With respect to the rest, I received several questions about when the recording will be available. There is a couple of remarks that I would like to say. First of all, that the recording will be made available in about 24 hours from now. So you will all receive a mail from the webinar system with the link to the recording. The second thing is that with particular reference to VI-WorldSim, we have uploaded the recorded demo snippets on our YouTube channel. I think that Scott said this in the presentation also, but I'd like to mention that again. So you can go visit our YouTube channel. You will find a playlist dedicated to VI-WorldSim, and that contains both the essentially the Roadrunner ModeKit demonstration of how to generate a new environment and import in VI-WorldSim, as well as the recorded demo of the offline usage. The third thing is, if you're interested in receiving a demo of both VI-WorldSim or VI-Car Real-Time, I will now start a poll, which you can use basically here. So you should be able to see a question window, and you can just select the appropriate essentially entry if you'd like to be contacted by us in the following days, basically, for dedicated and private demonstration and more detailed demonstration, basically, of one of these products or both products. I would essentially close the webinar by thanking once again Scott Bergeon for his essentially for his contribution with respect to this webinar titled Accelerating Vehicle Development with Real-Time Software Solution. I also would like to invite you to visit our website, making sure that you particularly visit the page dedicated to our real-time software, where you will find more information and more detailed information about the software products that we have presented today. Last but not least, I would like once again to remind the actual release date for essentially for the newer version of the products that we have mentioned today, which is the 24th of November. So please look out for our website, especially in the download area. The software will be disclosed in that date. So this said, I would like to thank you all once again for participating, and I hope to see you soon in our next webinar initiative. Thank you very much, and have a good day.